Alright, so we're going to start a new chapter today. It's chapter 9, and we're going to be dealing with rational expressions. One thing and today is the 31st, it's my brother's birthday. His name is Justin. It's going to be section 9.1. We're going to be graphing rational functions. And this will be day 1. Now, one thing that I posted in Google Classroom was I posted some notes. This is what I got from Mr. Cilio when I was a student of his. When he was my student, when I was a student of his, so when he was my teacher, he gave me all these notes, and when I graduated high school, I didn't want to throw away my math notes, and I went to college and got a math degree, and then when I got hired at PV and I was told to teach math, I still had all the notes under my bed, so I took them out, and this is one of the note pages for this chapter. So what I want to do is just, you could use these notes if you want, but I'm going to try to give you some notes that I think are a little bit better. Just please don't tell Mr. Cilio that. So, what a rational function means, a rational function looks like this. You have a normal function divided by another function. Any of these functions could be linear, they could be quadratic, they could be cubic, quartic, or irrational. If we combine them into be a fraction, that's called a rational function. Now, if we want to know what a graph looks like, we could always just plot points. The general shape of a rational function would look like this. Where these are called branches. That's what the actual graph looks like. But in order to get the branch, we need to have a scaffolding or something to give the graph structure. I'm going to draw dotted lines here. This dotted line represents a vertical asymptote, or a VA. Now, an asymptote is a line that a graph gets close to. This line up here represents a horizontal asymptote, or an HA. So we have to figure out how to get the branches, the horizontal, vertical asymptotes. So let me go through how to do that. And we'll do this by looking at an example. Let's say f of x is equal to 1 over 2x minus 3. Or let's make it a little bit easier. Let's just say x minus 3. In order to graph a rational function, there's 4 steps. Very first step that we do is we make sure that we factor completely. We'll be using this more tomorrow. What's going to happen if we factor completely is whenever we cancel factors, we're going to get a whole when it equals 0. So for this problem, it doesn't matter. There's nothing to factor, so let's move on to our second step. The way we find our vertical asymptote is we set the denominator equal to 0 and solve. Very easy. In this case, our denominator is x minus 3. If we make it equal to 0, x would be 3, would be the vertical asymptote. So I'm going to go ahead and set this up. And 3 would look like this. You could have more than one vertical asymptote, but for this problem, when we set our denominator equals 0, we did just get 1. Now the third step is a little tricky. To figure out where the horizontal asymptote is, what we do is we compare the degrees of the numerator, which we use n to represent, with the degree of the denominator, which we could use d for. Now if the top power, and remember a degree is just the highest power of x, if the highest power of x in the numerator is smaller than the highest power of x in the denominator, your horizontal asymptote is just y equals 0. If the top power, or the top degree, is equal to the bottom degree, y would equal the leading coefficient of the numerator divided by the leading coefficient of the denominator. This would be a problem like if you had y is equal to 2x plus 1 over, say, x minus 2 or something. We can't factor that, but because the degrees are the same, the horizontal asymptote here would be y is equal to 2 over 1, the leading coefficient of the top divided by the leading coefficient of the denominator. That's not related to this problem. That's just kind of like a separate idea to demonstrate that. And the last thing that could happen is if the top power is bigger than the denominator, that means that there's no horizontal asymptote. We're going to use long division to find a slant asymptote. We're not going to be doing this today, but that is a possibility, so I just want to make sure your notes are complete. So let's take a look at our problem. We have 1 over x minus 3. The top degree, there's no x, so we say the top power is 0. Bottom degree would be 1. So the top is smaller than the bottom, so y would equal 0 would be our horizontal asymptote. Let's make this one red also. All right, so we have the scaffolding. Now let's figure out where our branches go. So the way that we figure out where the branches go is we test x values to the right and left of each vertical asymptote. And we're going to get a point from the simplified function. So let me explain what that means. For the problem we just were working on, our vertical asymptote is 3. So I'm going to pick a value to the right, like 4, and I'm going to pick a value to the left, meaning 2. And I'm going to plug those values into my simplified equation. Now, we didn't have to simplify it, so I'm just going to use the original. If you plug in 4 for x, y would be 1 over 1. So the point 4, 1 is on the graph. If we plug in 2, we get y would equal 1 over negative 1. So that means the point 2, negative 1 is on the graph. And from these points, we are going to approach the asymptotes. And that's what the graph would look like. So that's how we graph rational functions. I'll do one more, and then I'll give you your homework. If you have any questions, just raise your hand and let me know. and I'll stop and I'll answer your questions. All right. Does anyone have any questions? All right. So nobody's yelling anything out, so I'm just going to go ahead and graph one more, and then we'll talk about your homework. The problem looks like this. Step number 1, we can't factor. Remember, if we factor, we get holes on the graph. We'll talk about that more tomorrow. Second step is to get the vertical asymptote. We set our denominator equal to 0. So that's pretty easy. I'll go ahead and set this up. The denominator is going to be x equals 0. So now let's go to our vertical asymptote, our horizontal asymptote. And if we look at the top power, it's 1. We look at the bottom power, it's 1. So the degrees on the top and bottom are equal. So in order to figure out what our horizontal asymptote is, we say y would equal the leading coefficient divided by the leading coefficient, or 1 over 1. Y equals 1 looks like this. So now let's move on to our fourth step. For our fourth step, to get the branches, we're going to pick points to the left and right of each vertical asymptote. Sometimes there could be more than one, but in this case, there's just one vertical asymptote. So I'll pick a point to the left, -1, point to the right, 1, and I'm going to plug those in. And if we plug in -1, we would get y is equal to -2 over -1, which is just 2. So the point -1, 2 is on the graph. If I plug in 1, y would be 1 minus 1 is 0. 0 over 1 is still 0, so the point 1, 0 is on the graph. I'm going to approach the asymptote, and I'm going to approach this asymptote. Same with this point, just get close to each asymptote, and that is how you graph rational functions. For homework, what I would like you to do is on page 554, I would like you to please do numbers 18 to 26 even, and on practice 9-1, I would like you to please do numbers 3 through 6. Please attach that homework to this assignment by midnight tonight. Thank you very much. Have a nice day.